Hello and welcome to our lesson today on gravity and tides. This is for Middle School Standard Earth Science 1-2. The essential questions for today's lessons are: what is gravity? What role does gravity play in ocean tides? And what role does gravity play in the orbital motion of planets, their moons, and asteroids in the solar system? Our vocab words for this lesson: gravity, orbit, neap tide, spring tide, weight, mass, and inertia. So we're going to start with what is gravity. So now the universal law of gravitation states that everything that has mass has gravity. That means absolutely everything. A single tiny atom has gravity, as much as a star or a planet or anything else. Just the gravity from very, very small things we don't feel like we feel from the gravity of very, very big things. And that's because of a couple of simple laws that have to do with gravity. Now, this slide shows some of the more complicated physics and math associated with gravity. But what's important for us to know are two key facts. The bigger something is, the more gravity it is. So mass and the amount of gravitational pull that something has is linear. The bigger it is, the more gravitational pull it has. The second important thing is the closer an object is to something, the more its gravity impacts something. That's why when you're standing on a planet, you're more impacted by its gravitational pull than, say, if you were in a spaceship orbiting around the planet. So now, how does gravity function to keep planets and other things in the solar system in their orbit? Well, it's actually a combination of two different forces. We know that gravity is the pull that all objects that have mass have on other objects that have mass. So, if gravity were the only force working in the solar system, the sun would crash into the planets, the moons would crash in, everything is attracted to itself. So there's got to be something else going on. And that thing is inertia. You remember back from when you were studying Newton's laws, you remember that one of Newton's laws is that an object in motion remains in motion unless it's acted upon by another force. Another way of saying that is it's the tendency to remain unchanged. Things don't like to change their direction they're going in. They don't want to speed up. They don't want to slow down. Left to their own, they would stay the same. So when you have gravity pulling something towards you and inertia wanting it to go in a straight line, the result is the circular orbit that we see of moons going around planets, or planets going around stars, or other celestial bodies like asteroids, which also travel in orbits much like the planets do. Mass and weight are used almost interchangeably here on Earth. When we say things like, how much does something weigh, we can say it weighs 10 kilograms. But in reality, what we're using the word weight for, we're really talking about something's mass. And remember that your mass is the culmination of all of the atoms that make something up. Mass is measured in kilograms. It always remains the same. No matter where you are in the universe, your mass remains the same. Your weight, on the other hand, changes because weight is the relationship of the gravitational pull upon your mass. And your weight is actually measured in newtons. Remember Sir Isaac Newton? Well, Newton is actually the unit of weight. So, what does gravity do to influence the oceans on Earth? We know that Earth is mostly covered with water. So, what is it that makes high tides and low tides, and sometimes tides are higher than others? So, what's going on with that? Why do we have these tides? And it really has to do with the gravitational pull of the moon on the Earth. Now, please remember in this picture, the sun is much farther away than this. It's just a graphic that has the sun in the picture. Because what's important to look at here is the relationship between the sun and the moon and the earth. Because this is a picture of springtide where all three of them are lined up with each other. So what's going on here is it's actually the gravitational pull of the moon pulling on our water, which kind of causes the water on the earth to displace outwards, and it happens on both sides of the earth. The reason that it happens on both sides is a factor of the earth spinning and of our orbits around the sun as well. So when the moon is in line with the sun and the earth, so you could draw a straight line between them, we have our high tides. Happens on both sides of the planet, and we call that our spring tide. Now, as the moon orbits around the sun, that changes. So in this slide here, you can see the different positions of the moon and what it does with our tides. You'll see that the tide indicator is switching between neap and spring. And when the moon is lined up, we have a spring tide. And when the moon is at right angles between the earth and the sun, we have what's called a neap tide, which is the lowest of the low tides. Spring tide is highest of the high, neap is lowest of the low. And this graphic also shows you the phases of the moon in each one of these positions. Remember, it takes about a month for the moon to orbit the earth. So we will have our highest of high tides twice a month and our lowest of low tides twice a month. One thing I want to point out to you when you're looking at graphics like this or at other pictures where you're showing images of the earth and the relationship of the moon and the earth and the sun, we're actually looking down on the earth as if you were above the North Pole from here. So when we're having our spring tides, you're looking at where it's bulging out is, around the equators and around the sides of the earth. So the tides are more pronounced.